Great, great. So, before we start, do you have any questions? Did you try to attempt the H-based subjective question? No? Okay, okay. So, yeah, but give it a try. And, alright, so yesterday we talked briefly about Zookeeper. So, here is a question for you. Imagine that you have one inbox, one inbox, and we need to process these emails. Maybe we want to index them parallelly, or we want to do something else on the inbox. And there are lots of emails in this box which are coming in, and these email processors which are running on multiple computers are reading these emails from the inbox, and and these email processors need to ensure that one email processor does not process the same email that is being processed by another another uh, email processor at the same time. Okay, so is the problem statement clear to you? Hey Lakshmi, hey Lakshmikant, good morning. And the question here is that you have an inbox which is being processed by multiple email processors running on different machines. How would you make sure that one email processor does not process the same email which is being processed by somebody else at the same time? So that's the question to you. It's an open-ended question, so feel free to answer the way you want to. There is no right or wrong answer in this. Read write logs. Okay. So where will you create these logs? Okay. Once it is processed, we can set some kind of flag. Or while it is being processed, we can set some kind of a flag in the inbox. Okay. That's good. That's good. Let's say we are not allowed to mark anything in the inbox. We only have read only permission. Yeah. Yes, Nivas. So user ID based on combination we can set one key, okay? Based on combination of user ID and message ID, we can set one key. We can set row label lock while processing. Okay, okay. So see, this inbox is an email inbox, and we cannot create in locks on this inbox. Okay, these email processors themselves have to decide. We are not allowed to write anything into inbox. Yeah. Okay, so Anand says that we can divide email into three parts and send each part to three processors. Okay, so first, when we are dividing the email into three parts, we are anyway doing the processing. So the purpose of multiple processes is anyway lost. Second, uh, the kind of processing we are talking about is one email per processor. Okay, but the idea is good. I appreciate that. Okay, okay. So Kalyan is saying we can keep a secondary table where we can keep a key field so that every processor has to check the secondary table before processing. Brilliant, brilliant. And yes, okay, good, good. So basically, what he's talking about maintaining another machine like this, where email processor is keeping basically a record that I am processing this particular email and do not touch this one, right? So yeah, when inbox is not allowing us to write anything or make the flags, then we need some third party to do that. And had it been a single computer, had email processors been three different threads running in the same memory, we could have created locks provided by the language constructs. Or we could create a variable which is static and which is shared across the threads, and we could maintain the lock over there. But since these processors are running on multiple machines, they are not even the same machine. Okay, so had it been so when your all the processes are in a thread, then you can actually do is you can maintain the memory. If the processors are different separate processes on the same machine, then we generally coordinate using a local file system. And when your processors are on multiple machines, then you need to use a networked service to communicate with. Okay, so this system with which these email processors has to communicate has to be really robust and should be able to provide a really high throughput in order for coordination. Okay, and this is what is the role of zookeeper. So this is what is the role of zookeeper. So we basically have, if we have zookeeper installed already, all these email processors can talk to zookeeper and maintain a list of the email IDs that are in the process. Also, all of these have to take into account that if a particular email processor dies while processing an email, the other node should be able to pick up the same email. Okay, so those kind of complexities arise when you deal with the multiple multiple machines and their coordination. So one email processor, first email processor started the reading email 1, and while it was processing it, something happened and it shuts down. Now, nobody will ever process the email number one because it will always show that. So, how to tackle such kind of challenges? And Zookeeper provides those constructs. Okay? So, is everybody comfortable with the idea of, you know, this part? This is the role being played by Zookeeper. Yeah? Anand? Okay. So that's a Zookeeper. Zookeeper is basically a distributed coordination system. Distributed as in running on multiple machines parallelly. And Zookeeper itself runs on multiple machines so that whosoever is requiring the coordination is confident on Zookeeper that it does not fail. Okay. Had our coordination service being running, had our coordination system was singular machine, it would shut down in unusual circumstances. All right. So those heavily distributed applications can utilize Zookeeper for the coordinations amongst them. And who uses this? So HBase uses Zookeeper. If you remember, the coordination between region servers and the coordination between region servers and HBase master happens through Zookeeper. The coordination between name node and backup name node happens through Zookeeper. In case name node shuts down, the backup name node takes its place, and this switching happens via Zookeeper. And there are other multiple services we will talk about which use Zookeeper. All right. So what is Zookeeper? Zookeeper exposes a very simple set of primitives which are very easy to program to, and it provides you a data model like a file structure. So you can think of it's like a folder structure, and one node who wants to inform that I am doing this, it just creates a file or it just creates a node in that file structure, and the other nodes will read from the same folder and find out that okay, this particular node is processing this email, and so don't touch it. Okay, so Srinivas' question is, suppose Zookeeper shuts down, who will take the position? Very good, Srinivas. So Zookeeper itself is a heavily distributed service. Zookeeper is run on multiple nodes. Okay, it's not a single node system, meaning just like so we'll talk about that. How does it behave when one machine shuts down? All right. So Zookeeper is designed in a way that it's is probably out of all the services which we have discussed so far. We have discussed the HDFS, we have discussed HBase, we have discussed we have discussed yarn, and everywhere there was a sort of master slave. And Zookeeper actually is far better than most of the systems we have discussed so far when it comes to the fault tolerance. All right. So Zook uses it is used for heavily synchronization, configuration maintenance, and coordination. It's a brilliant coordination service which do not suffer from race condition and deadlock. So we are talking about few things here. First, Zookeeper is a great distributed service which runs in the network. So you might ask that when it can store data, it's running in the network, and it's really heavily distributed and highly available, then why don't we use this instead of any HDFS, right? You might ask this, right? And so So you might think that why don't we start using this for our storage of the data? Okay, so that's the catch. So Zookeeper is great as coordination service, but it's not great for storing huge data. Okay, it's not great for storing huge data. If you have to store kilobytes of data at one single node, and you can have few million nodes, but not beyond that. If you start storing far more data, the Zookeeper does not behave really fast, and it does not scale well for more data. But it scale well for more number of connections, and okay, all right. So these are few design goals. A shared hierarchical namespace that looks like a standard file system, and the namespace has data nodes which we call Z nodes. It is most of the data is kept in the memory. Now this is another reason why you would not like to use Zookeeper for storing lot of data, because data is in memory. Okay, it achieves high throughput and low latency numbers, and it's really high performance and used in large distributed systems. Okay, highly available. There is no single point of failure at all, and it provides you a good synchronization, as in the thread safety. In thread safety, what we had put is that we were able to define transactions, which we were able to define what is atomic, what is not. So those kind of constructs are provided by Zookeeper to you. So Kalyan's question is, it is a kind of interface unit. Okay, I need to understand what do you mean by interface unit. So it's basically a full-fledged service which is running, and we can create nodes in it, just like we can create folders and files. In the same manner, we can create nodes in it, and we can store data on each node in the form of binary or plain text, whatever you want. So connects different systems. It does not connect directly. This is all the machines, they talk to it and write the data and read the data from it. So you can imagine that it's like a centralized file system. It's like a centralized file system, but it should be used only for storing small data, not big data. All right. And then it is heavily replicated, meaning it runs on multiple machines simultaneously. So you have the way it works is the design is you have multiple servers, multiple zookeeper running a service on multiple machines. One of them is chosen as the leader, and rest are followers. Every write request goes to the leader, and the followers are only used for the reading the data. Okay, so similar to name node, data node, in that sense that there is a single master, but as opposed to the name node and data nodes, In case of name node and data node, we designated a machine as name node. Here, they automatically designate one machine as the master, where all the write requests, whenever clients wants to write the data, change something, all those requests go to master node. Okay, we call that leader, specifically in terms of zookeeper. So all the write requests go to the leader, all the read requests go to the followers, and the election of the master is done by all the nodes together. All right. Now now you might wonder that how does it work then when it's highly available? There are so many machines. How you as a user of you as a user of Zookeeper, how are you going to contact this? So it's pretty simple actually. There is a client library, and that client library provides hides all the complexities from you. This client libraries underneath keeps the TCP connection to Zookeeper, and this client library, as soon as it opens the connection, it keeps sending the heartbeats to the server saying, hey, I'm still alive, I'm still up. The moment the server stops receiving these heartbeats, the server assumes that the client has got disconnected. Okay? And also, the client keeps on getting watch from server. It's like the reverse way. Server keeps on sending you the events like this particular node had changed, this particular node have modified based on what client subscribes to. Okay. So everything is starting with as I told you that the whole of the data is in the memory. That does not mean that if machine shuts down, the data is lost. No. Whatever is there, whatever Zookeeper has created, what we have created in Zookeeper, whatever data we have created, that data is loaded in the memory as well as persisted in the disk. While transaction logs and snapshots are only kept in the disk. Alright, next is that it provides you a billion transactions. Every update, whether you are writing to Zookeeper or reading from Zookeeper, it maintains an internal number to to record the sequential entities. Okay, so order it can easily order the updates based on this number. All right, it's really fast. It performs best when reads are far more common than writes at ratios of around 0 to 10 to 1, meaning 10 reads and 1 write, and it performs really great. At Yahoo, where it was created, the throughput of Zookeeper cluster has been benchmarked over 10,000 operations per second for dominant workloads generated by hundreds of clients. All right. So also note that in one of the papers from Google called Google File System, they have described a service called Chubby service, Chubby Chubby service. So basically, Zookeeper is an implementation of Chubby service. All right, and so you can see that now. It provides you two kind of interface. One is a four-letter interface where we basically ask the things like, "Are you okay? Give me the status." So for basic interface, you can basically connect to this port, and say, "Are you okay?" Okay. Let me show you. So these are four-letter commands for basic operations. Just to and you can see that What is more important is this syntax, what we are doing here. What we are doing here is we are saying, are you okay? To, we are piping this. This is a pipe. We are piping this to localhost. Alright. Here you want me to increase the font. Now, alright. Looks good, better now. Okay. So, so right now we are logged in here and we want to say hi to our zookeeper. So let's just connect and let me say localhost here. So either we can connect to this service and then type, okay, so it says in the response it says I am okay. So 2181 is the port number, localhost is the machine name, NC is the command to connect to any of these things, any of these services, similar to telnet or SSH. We can connect to a port, any service using NC. So we said connected to this, and I said, "Are you okay?" And then it replied. Similar in the similar way, we can also pipe things to it. We could say, "Are you okay?" Right? So it sent "Are you okay?" to this command, and it gave the response like this. All right. So we can also check the status. We can check the status of our zookeeper. All right. Now it says that these are the various machines running, and the latency minimum, average, and maximum has been this much. Total data received this much, and connections 11 total, and mode is standalone right now. Okay. All right. Okay. So here are few more details. All right. Now, there we can see that we were able to communicate with the zookeeper, and you can try other commands. If you want to start it in the standalone mode, where it's only a single node, ideally it should not be. Alright, alright. So I need to check why it's not running parallelly. It's right now running in standalone mode. So if you want to just run Zookeeper, Zookeeper does not depend on HDFS or any other service. It's independent service. Even HDFS depends on Zookeeper. So okay, so Vivek's question is, what confuses me is that are you okay output is being passed to NC command. That sounds opposite. It's not actually. I'll just show you. So what does it mean? What does echo means first of all? Echo means echo it to the standard output. Now we are saying pipe it to NC localhost, meaning pipe it to the socket which is 2181. So this is our socket. We are connecting to localhost at this port. And this connection will get whatever echo is saying. Whatever echo is saying here, that gets piped here. Alright, great. So you can simply download it and start it, and this will start immediately. So you don't need any other service to run Zookeeper. Alright, so next is the data model. Alright, the next is the data model, and it is important. Uh, so when you connect and talk to Zookeeper, this is how it would look to you. So it will be like a classic tree starting with slash, and you can keep on creating node under slash or under any other node. Okay. Now it looks like a very highly available file system. Just the difference is there are no files. It only has nodes. So every node can have children, and every node can have data in it. Okay, data you can put any data in this, and you can delete the nodes. And the way we are going to represent is in the similar way we are representing our file structure in normal file system in Unix, starting with slash a slash b slash c and so on. It doesn't have notations like dot or dot dot. Both are invalid. And you can either write the full data into node or read the full data from the node. Okay, you can either write the full data into the node or read the full data from the node. You cannot edit the data. Okay, you cannot append to the data. Alright, and when we are accessing the data or writing the data, both operations are atomic. Either the full data is written to the node or nothing gets written to the node. Alright, and then these are, each node is called z node. So we have slash by default. We created zoo under the slash, and then we created duck under zoo and goat under zoo and cow under zoo. These are the names of node. We can have data on each node, and data is simply like a string, big string, which we can store on each node. Okay, now when it comes to the G node, there are multiple kinds of Z nodes. Z nodes, Z node is the same thing. I'm just pronouncing it differently for different audience. So Z node is persistent. There is one kind of Z node, the default one, which is persistent, which means it remains there until deleted. Ephemeral node, we create. There is one feature which Zookeeper provides you called ephemeral node. These nodes disappear as soon as the client who created them disappears. These are ephemeral nodes. So if the client is there, if it created a node and after some time the client got disconnected or client got killed or client itself disconnects, these nodes, the ephemeral nodes, will just disappear. Ephemeral nodes cannot have children because that will create a lot of confusion. Because if an ephemeral node is to disappear, then all the children should also disappear. Therefore, ephemeral nodes generally are not allowed to have the children. Okay, so and also the ephemeral nodes cannot have even the ephemeral children. Okay. Even though an ephemeral node is temporary node as long as the client is connected, but it can have the data, it is visible to other nodes, and other properties are same. So if we have to read some data from slash g node slash duck, have to go through slash and z node of slash duck. So no, but the zookeeper provides us the facility to read the data directly given the file location. Okay, given the node's location. So we tell zookeeper, give me the data from slash g node slash duck. Okay, or in this way we can say, we can simply say to zookeeper, give me slash zoo slash goat. Okay, all right. Now there is a third kind of a node called sequential node. Okay, these sequential nodes are partially automatically generated. You provide the prefix and it adds a suffix with a number. Okay, like you can see that create minus s slash ju v. Okay, v is the data, so I think we should get hands on now. Okay, we should get hands on now. So I am connecting to zookeeper. All right, so we can say ls slash. So these are the nodes under the top node. Okay, under the top node these are the nodes provided to us, and under each one you can see ls slash fab 28. These are the other nodes. Okay, so let's just create a node for this class. Let's call it may2. Okay, and we let's put so it says create this particular node, and we put some data. This is may2 class. Okay, so we have now created a node with this one. Now under this we can create ephemeral nodes. We can say create minus e slash may2 and my eph. So this node disappears. So this particular string what I've just written is the data on that node. So now you can see I can say may2. Alright, now there is only one node. Now under this node, under this may2, we can create a third kind of a node called sequential node. And in sequential node, we can optionally provide a prefix like x. It automatically will, sorry. So yeah, let me just copy the same command. So we have to also, yeah, minus e means uh, ephemeral node, and minus s means sequential node. Okay, earlier we created an ephemeral node, and now we are creating the sequential node. All right, so I'm just typing something. This is some information we want to store. Okay, this is some information we want to store. Now you can see that we said create x, but it created x001. So it automatically appends the node with a number in case of sequential node. When we are creating a sequential node, it basically takes the input as prefix and appends a number with it. Okay, if you want to get the information what is there in may2, and we want to say, alright, so we can see the data inside it, and it has basically truncated all the information after space. So I think it does not accept space in this, or maybe I'll have to use some other format. So now you can see that we created another node with the same prefix, and this time we got 2. All right. And in case we are creating a normal node, it will basically create a normal node. And again, now did you notice something? The sequential node is basically a count of total nodes in under a node. Okay, so I'll show you. So under this, there is one node called x, and my ephemeral node has disappeared. Why? Because we got disconnected once. There was an error and it disconnected us. That is why my ephemeral node has disappeared. So the disconnection was helpful in demonstrating that the nodes disappear. If you see this, okay, so this is where we created our ephemeral node. You see this? May this, and when we said ls, it was there, my EPH, but after that we got an error, we got disconnected here, and then we connected again, and because of that our node has disappeared. Alright, because it was an ephemeral node. Slash may2. Okay, now let's say we create one more node called may2, and I give it a name as some node and put some data in it. Okay, now if I create an ephemeral node with some as prefix, what will be the node's name? You can see that the previous ephemeral node's name was x00004. What will be this node's name, what we are trying to create just now? We are trying to create ephemeral node with the prefix some. So what will be the name of the node? Can anybody guess? Okay, Anand says some 001. So see, if you Kalyan, if you noticed, when we are creating, okay, sorry, it has to be minus s. Yeah, so when we are creating the sequential node, a number is getting generated, and that number is based on the parent node. Okay, every time you create a node, this number gets incremented. All right, so first time we created ephemeral node, that was 0th node, and then we created the first the sequential node. So in sequential node we provide the prefix and a sequential number attached to it automatically. So here, yes, Srinivas is right, it is going to be 0056. Why? Because I think we have created more nodes in it. Yeah, so alright, alright, I'm still wondering how come. So this time it is sequential. So basically it keeps on counting. Okay. So the first node, the 0th node was ephemeral node. Then second node was this one. Third node was this one. Fourth node was this one, and the fifth is this one. and the sixth one is sum, and seventh is this. Yeah. Okay. So 005. Okay. So every time you create any of the node, it's the, yeah. So now if I create another node, let's say, okay, let's say a normal node, let's call it some new. Okay. Now you can see May 2, it is created. Now if I create another sequential node, what will be its number? Correct. Its number will be 9. Alright, because, alright, so every time you create any node, it basically increases the number under parent. Okay, so what if I create this? What will be the sequential number? It's good, Srinivas. Just that the number starts with 00. Okay, not 1. Alright, so this counter is a property of the parent, and it keeps on running every time you create a child node under the node. Okay, so is this clear to everybody? If it's not clear, I can try out few more examples, and that will give you more confidence on the way the sequential number is being generated. So every action which is happening at the node level has got a counter, has got a sequence number running. It's just that when you want to generate a sequential number, that number is put into use. Alright, is it clear to everyone? Anand, any doubts? Yes, this is the child, correct. So but it's a sequential node we are creating. So whatever name we give there, automatically Zookeeper appends it with a number. And if we do not provide any name, what it does, it basically assumes you are providing an empty string. You see this? So it has created the next node without any prefix. Okay, okay. All right, all right. Yes, let me try to do another round of summary. So today we are discussing something called a zookeeper. Zookeeper is a central service to which all the people connect and coordinate by writing the data, right? When you had multiple threads, you used locks provided by the compiler, and which you have multiple machines. If you have multiple machines, sorry, if you have multiple processes on the same machine, then you use file system, local file system for coordination. But if you have multiple different machines and they want coordination, as in if one is doing something and we do not want the same thing to be done by others, and this way the coordination is required. They want to, just like we need a policeman in the on a red light in order for the coordination, or do we require red light on a signal so that the coordination can happen, so that the traffic does not hit each other, and that's where the role of a coordinator comes into place. So zookeeper is a central service. Everybody talks to zookeeper and takes the update. And Zookeeper provides a construct like a file system to which the users can write or read from. Okay. Under that file system, you have, just like folders, you have nodes. Okay. In the file system, there are two things. One is folder, other is file. Here, in case of Zookeeper, it's only one thing called Z node. Okay. So you can think of Z node as something like a Z node can have children. Z node has a parent. Z node can have the data, and people can read or write from the Z node. And all the clients can create Z node. There are multiple kinds of Z node. One is sequential. One is normal one, which is persistent one, which basically remains there forever, as long as you don't delete it. Then second kind of Z node are ephemeral. They remain as long as, so you create, as long as the connection remains connected. So if there is a client who connected and created an ephemeral node, if it gets disconnected, the ephemeral node disappears. And there is something called sequential node. These are the node in which a number is automatically attached to to the name you provide. Okay, so in a sequential node, a number is automatically appended to whatever name you are providing, and this number is a running counter of total number of nodes under a node. So as we created earlier, this node, if we create again, the counter for this will be 002. So it's a running number for slash may2 slash sum. So for this node called sum, the total running count of so far is 2. If we create one more, the next node's name will be 003. So what we are trying to do is, if you see may2 slash sum, under this these nodes are getting created. Okay, and we can also create the number, another node with a normal node, not sequential node, under this folder. So may2 Srinivas, it's yeah, let me, yeah, so you can see that we created a normal one this time without sequential, so a sequential number was not appended to it. Next is that, okay, now if we create a sequential node with some other name, say, alright, this is some prefix which we are providing for creating a sequential node. Now you can see that the running count was increased, and now it is 5. Okay, so earlier there was 00, then 1 was given to this node, and 2 was given to this node, 3 was given to this node, and 4th was given to this node, and 5th was given to this. Okay, so there is a running count, there is a counter keeps running for each node. Okay, as soon as you create nodes under this, that number keeps on increasing. Even if you delete, that number will not decrease. And whenever user expresses a need for a sequential node, it automatically appends that number, the running count, onto the node and increases the running count. Okay, all right, so that was a very quick summary. I hope that gave you an idea. No, you got it right, Manish. It actually, the Zookeeper is being used by HBase and region servers for coordination with each other, and so and similar is case of data node and name node, and also to keep an high availability of name node. Okay, so name node and backup name node, they both inform Zookeeper. They basically create their own Z nodes, and that gives a good idea about to Zookeeper. And all the clients who are connecting to any service, they also talk to Zookeeper and ask for the nodes which are up. I'll show you some more things. All right. So, can you? Okay, I will explain some more things to you. Uh, all right. So, Kalyan's question is, can you please tell me again about the difference between the nodes, functionality wise? Can we have sum this hello here? Hello will also become the child. Yes, hello will also become the child. That's correct. Okay. So let me just create. Okay. Let me create a normal node, not sequential node. Yeah. So it says that this does not exist. Okay. First we need to create the parent node. May sum. Okay. May to sum. Sorry. So we can say this one because this one is okay, or we can say this 0 0 and then create a new node under that. Okay, we can create a new node. Okay, and we can put the data in it, some random data I'm putting. So now it has created a node under this. All right, you can see that. Tarak, is that your question? So what is the maximum number of node? That's Tarak's question. So I don't know exact number. Okay, I don't know upper. Okay, and Manish's question is, so is zookeeper just some kind of controller? And for example, if we are using in Hadoop, will each data node attach to each zookeeper node, or I got wrong? So yes. So there is a zookeeper central service, and all the people keep on informing it. So I'll show you this. I think this will be better idea. So yesterday when we were talking about HBase, we were talking about reason servers. Now the discovery of reason servers happens through Zookeeper. Okay, so whenever a reason server comes up, it updates itself into Zookeeper, and I'll show you. It basically creates ephemeral nodes in the Zookeeper. So here you can see that there is one folder called hbase in unsecure. Okay, we have kept it unsecure so that we can show you this thing. So under hbase unsecure, we have meta region servers, and there is something called running here. Okay, so under running there is no servers right now, and also we can have a look at master. So master also is not there right now, and let me just see what's going on. Are all region servers down? Yeah. So these are the region servers which are up. Hadoop 2 and Hadoop 4. Okay, let's have a look. So what I'm trying to say is that when a region server comes up, it basically creates an ephemeral nodes here and ephemeral nodes here, so that in case it goes down, the ephemeral node disappears and master will know that that region server is down. All right. So we have hbase. Where is hbase? Here it is. Okay. It says that 2 out of 3 region servers are alive. Okay. So you can see that there are only 2 servers, Hadoop 4 and Hadoop 3, which are up. So it basically stores the region servers into this folder. We can get the information about these region servers from here. Okay, we can say get. It'll give us all the information. So see, it is storing the binary data here. You can see the binary data, and also here it's also putting the port number and all. And it's a ephemeral node. Okay, it's a ephemeral node. All right. So we can say help here, and all right. So we can say stat. Stat basically shows us that the status of the node, when was it created. So you can see this Hadoop, what all were there just now. So LSRS shows us all the region servers. So Hadoop 2 and Hadoop 4 are live, and Hadoop 3, it says that the following component is down. When I turn it on, when I turn it on, so Hadoop 3 region server. So I'm turning on the region server which was running on Hadoop 3, and it will get up quite soon. So we'll keep on doing ls here, and as soon as that service comes up, it will write to Zookeeper and it'll inform Zookeeper about this. So you can see that Hadoop 3 came in. Okay, so the kind of work we are doing right now, we are continuously checking Zookeeper about region servers availability. In the same manner, HBase master will keep on querying Zookeeper to see the list of all the nodes which are there on this machine. Okay, so the moment this machine goes off again, so we can actually, I think we can shut it down. So let's say on Hadoop this 2, we can stop it. We can stop the region server on Hadoop 2. Okay, so now you can see that after some time that ephemeral node should disappear. Is everybody okay with the concept of? Now you can see that it has disappeared. So this way the coordination is continuously happening. So now HBase master, when it comes up and asks, can you give me the list of region servers which are up, it always gives you a fresh list. Okay, it will not give the HBase a stale list of region servers, and that is one big deal in coordination. Similar is the case of master node and backup master node. All right, and as soon as the so if we have 50 region servers, HBase does not need to monitor, HBase master does not need to monitor all 50 region servers. All it has to ask is, it has to ask Zookeeper only. Now, what is the utility of sequential? Is everybody good with me? What am I trying to explain now? So Manishi's question is, what is the utility of sequential node? Have you used any ticketing system so far? When you raise a complaint to your internet service provider, they give you a ticket number. And when it comes to ticket number, this number generation, it's actually a big science. Okay? So lot of time you need to create a automatically create a folder which should not conflict with other folder. In all these circumstances, you need a sequential node. All right. So that way, basically, for generation of the number automatically, sequential nodes are utilized. Okay. Like for example, every time an email is received in Gmail servers, and every time these nodes have to create a new number. If you see the ID of the every email is designated an ID, so this ID generation becomes pretty complex if you have, say, hundreds of machines receiving the emails parallelly. All right. Okay, so I think that explains. Now, Manish's question is master node also ephemeral? So in yeah, so question is, the G node that is created by master node, will it be ephemeral? I think it will be ephemeral. I really don't know where it is created though. So here it says backup masters, for example. So backup masters will be another backup of the master in case the master stops running here. Okay. So you can see that it's an ephemeral because there is an ephemeral node here. And I'm not sure if it is. Yeah, when the ephemeral owner is actually 0, then it is not ephemeral, otherwise it's ephemeral. Okay, so you can see that. So master node is ephemeral, yeah, and so right now it is showing that there is one master here in the there is, because there is only one master node, so master node does not have folder. Instead, master node's IP address is written over here. You can see that the master node is hadoop 1.no big data. So this information is in the info of master rather than the child node under the master. Okay, but backup nodes, you can see the backup master, the backup of the masters would be listed here, but we don't have any backup masters. Okay, so similarly, other services will also create their own nodes here in order for communication. All right. So I can. So we have HBase here. We have, all right. So under Zookeeper, all right. Any questions still here? Going back. Next is watches. So every time you you query the system, you can also specify watch. Okay, and watches are only triggered once. Whenever you want to get the notification from Zookeeper, you can specify that as a watch. So whenever you say ls or get, you can also specify a watch. And these watches are triggered only once. And the command line does not provide you the command line does not provide a construct for adding watches, but all the API calls do provide you the watch. And the only thing is the watches are triggered only once. Okay, whosoever is watching it, they are called watchers. So watchers will be triggered only once. And if you want to keep on triggering again, getting triggers again and again, so you will have to re-register. Yeah. Is it possible to have child node of sequential as ephemeral? Yes, that's correct. We can have, so a sequential node is a normal node, just that it has a automatically generated ID. But we cannot have any children for ephemeral. Ephemeral nodes are not allowed to have children even if we want to create ephemeral children. All right. Did I miss anybody's question? Okay. So these are the watches you receive. The watches of creates whenever you are creating, it creates a Z node. Okay. So these are various commands. You can delete a node. You can ls. You can get the access control list. Who can access a particular file, a particular node. So on each node, you can also provide the security. Okay. And you can get the data and then synchronize. Right. Now, these whatever we had done, like creating a node, updating a node, or setting the data, all of these commands can be batched together in a single batch. And this way we can implement a multiple commands uh, transaction, which means that either all of the commands will succeed or all of these commands will fail. Also, the intermittent data, say if you are executing two commands, the data after first command executed will not be visible to anybody. Nobody will see the intermediate state will not be visible to anybody. Instead, the whole change will be visible to the end user. Okay. Correct, that is correct, Srinivas. So in context of HBase, it doesn't use sequential node. I don't know if it uses sequential node. At least I haven't seen yet. Alright. Now, there are two core APIs. One is in Java and other is in C, and rest are all contributed APIs in Perl, Python, and REST interface. Okay. Also, for each API version, there are two kinds of APIs. One is synchronous and other is asynchronous. Synchronous is when the function returns some value. Okay, means we wait here, we execute the function, we wait the function's completion, and whatever values are returned by the function, we take it and starts using it elsewhere. But in case of asynchronous API, we fire a function and then we tell the system that once this function completes, run some other function. Okay? So this function will keep on running in the background. It will not stop the execution of rest of the statements. Okay, that is asynchronous API. All right. Now we talked about watches quickly, and so so whenever we are creating the data or checking for the data, we can provide watches like when we are checking exist, get data, get children, create children, or and delete data. So various other events are various watches are triggered. So watches of exists are triggered when the Z node is created. So if you want to check whether a Z node is existing or not, you generally use a command called exist and pass the watches along with it. And these watches are will be executed as soon as the node you checked for either created, deleted, or data has been updated on that node. Similarly, watches of get data executes when the data is updated or node is deleted. Watches of get children are triggered when the data is deleted or any of the children is created or deleted. Also, there is the zookeeper provides you something called the access control list. But for access control list to make sense, we first need to enable authentication. In our current zookeeper instance, we have not enabled authentication. Okay, and so basically, first we need to define an authorization, and first we need to define an authentication, then authorization. Authentication means checking the login and password, and authorization means checking whether a particular user is given those permissions or not. Okay. There are multiple kinds of authentications which Zookeeper supports. One is digest, other is SASL, and other is IP, based on IP. Okay, SASL is the one which is preferred mode, and because digest for using digest again we have to maintain another set of login passwords. Okay, so ACL essentially is a combination of authentication and identity of that scheme and set of permissions. Okay, now let's talk about something called the architecture of Zookeeper. As we have seen, almost every tool runs in two modes: standalone and replicated. Standalone is only for testing and just learning purposes, while replicated is what we use in real-time environment. Okay, so in replicated, what does it mean? Instead of having Zookeeper run on one machine, Zookeeper is run on a cluster of machine which we call ensemble. So these ensembles will be running Zookeeper processes, and and basically as long as we have 50% machines up and running, Zookeeper will be able to serve you well. If there are equal to or more than 50% machines dead, Zookeeper will shut down. Zookeeper will make itself read only. Alright, there are two phases in the lifespan of Zookeeper. First is leader selection, and other is the broadcast. So the way it happens is it's actually a common, basically a common mechanism in whenever we have highly available service, for example MongoDB and Zookeeper, and same is with CouchDB and other systems. So everywhere the method is that all the nodes elect one node as master, and that master will do all the writing, while other slaves will keep the reading the data. Okay, this is something which is called Paxos algorithm. Paxos is what is being used everywhere. So the way it happens is the first phase of the process is the leader election. So instead of, unlike our name node, data node, where we earmarked, we ourselves marked a particular node as name node, okay? Here it is by the election. So there is a leader whose role is, the purpose of the election is to elect the leader. And who is a leader? A leader is somebody who accepts your write request. Whenever you want to create a node or want to update a node or delete a node, all those data modification commands go to the leader. Okay? So what these all the nodes vote for each other, and based on this voting a particular node is elected as the leader. Okay, in case this leader fails, the re-election happens and another leader is chosen immediately. And once the leader has been elected, all the write requests are forwarded to the leader, and whenever leader receives a write request, whatever changes it receives, it broadcasts to all the followers. Okay, and when more than 50% followers have saved the changes, it responds to the user saying, I have written the data successfully. Okay, and okay, so so this protocol of achieving the consensus is atomic, like two-phase commits. And also please note that anything the zookeeper says I have written, it means it has written it to the disk, and it is persistent. It is not temporary. Okay. Now Lakshmikant's question is, what is the difference between MongoDB, CouchDB, and HBase? All are NoSQL DBs. So these are from different organizations. So in case of MongoDB and CouchDB, they are actually similar. I don't know the much of difference between MongoDB and CouchDB. Okay, just that MongoDB is a little bit more popular than CouchDB. Okay, but the both are same. But there is a big difference between HBase and MongoDB. Okay, HBase is like your normal files, normal tables, sorry, normal tables which has columns and rows, while MongoDB does not have columns and rows. Instead, every row every row is a document in the form of a JSON format. Okay, every row is a document. It doesn't have columns. It has only the documents, which is basically in the form of JSON. Okay, and so there is a huge difference between HBase and MongoDB, but between MongoDB and CouchDB, there is not much of a difference, and we'll discuss it once later in the last session. Yeah, how to choose between different types of NoSQLs, which problem. So we'll talk about it in last session. Okay, Manish? Kalyan's question is, leader can't be changed once it's elected. It can be changed. If it fails to respond, then it steps down and a re-election happens. So, okay. So Manish, you wanted an example of what? The election process? Okay. So basically the way it happens is there we initially say that okay, we turn on 10 machines. All of them are zookeeper, and we have not marked any of them as leader or anything. All we have told is these are the machines in the network which are running zookeeper, and all of these machines know each other. Okay. Now they themselves will start talking to each other, and will, as soon as they connect with each other, the election will start happening. Okay. And as soon as we turn on all the machines, they will elect, they will elect one of the nodes as the leader. Okay. And that leader will start accepting the write request. Now this diagram will give you a little bit more clarity. So whenever a write request is coming from the client, a follower is forwarding that request internally to the leader. Okay. Leader is accepting the write request as well as the read request. Okay. Now, why do we need to have a leader always is because we cannot support writes concurrently on multiple machines. If we support data writing on multiple machines parallelly, what would happen is the leader sorry, if there are multiple leaders in the network, what will happen is all of them will accept the write request, and the data will get corrupted, and which we will not know which data to keep and which one to which. There will be a big conflict of data, and therefore there has to be only single leader. All right. Now also note that any criteria for selecting the leader or its end, the way the selection criteria is the time taken for the ping. Okay. If these followers are pinging a leader, if it's responding to the pings in a slow manner, or it's dropping the packets, then that the votes go down. So the votes are based on the response of ping. So each machines ping to each other machines and notes down how much time the other one has taken to respond and how many packets were dropped. And based on that, each machine gives the vote to each other, and the one who has the highest number of votes is elected as leader. All right. Now, few more things. In case, in case, out of out of 100 machines, 50 machines shut down, 50 or more machines shut down, then is what will happen is there'll be no leader. There'll be no leader. Leader will step down. Okay, and there are very good reasons for it. So the system works fine as long as 50% 50% node, more than 50% nodes are available. Okay. As long as more than 50% are available, the system works fine. The moment 50% or more machines are shut down, there will be no leader. Only the whole system will become read only, and you can only read the data from Zookeeper. You cannot write the data to Zookeeper if less than or equal to 50% machines are available. If you have total number of 100 machines and 50% machines, 50 machines are down, then the zookeeper will not function. But if 49 machines are down and 51 machines are up, then zookeeper will work fine. Okay, so that is one important deal which is called majority tolerance for the majority. Now we will talk about this thing in a minute. So Manish, the client can be anybody. Client is HBase also. Okay? Client is HBase also. HBase is also writing data to Zookeeper, informing that these are informing information about master and other information. Similarly, region servers are also client who have informed Zookeeper about about their attendance. All the region servers have given their attendance to Zookeeper, and they all are acting like a client. So everybody is a client to Zookeeper. All right. Now let's talk about this, the majority part. Okay. So imagine that you had three machines in ensemble, A, B, and C. A is shut down. Do you think will there be any leader? Quickly. So who will be the leader, B or C? Correct. It depends upon the response. Great. Now, all right. So it could be the scenario that either B or C would become the leader, right? B or C will become the leader if A shuts down. All right. Any doubt about it? Depends upon response, as in depends upon the voting. If A shuts down, B will vote for C and C will vote for B, and whosoever gets better votes, that will win. Okay? So, uh, so if there are right now, how many nodes are available? Two nodes are available out of three, right? There were three total nodes, and two nodes are available. And two is more than 50% of three, right? 3 is 50% is 1.5, and 2 is greater than 1.5. Correct? Therefore, there is a election happening. In case in case after B was elected as a leader, B also sorry, after C was elected as a leader, B shuts down, which means that only one out of three nodes are available, which is less than 50%, which means it's not majority. Now, in these cases, what will happen is, since what will happen, do you think C will stay leader or C will step down? C is already chosen as leader. Yes. So C will step down. No one will remain the leader. Okay. C will become the follower and C will become the read only. The reason is only one out of three nodes are available. Three is the total number of nodes. Okay. No write operations will be supported. Okay. Okay. If you are, if you want to desperately start the system, you will have to shut down, remove A and B from the list, and then start up again. And then it will run fine. It will assume that there are total number of only one node in the ensemble. Okay. Now, question is, yes, again, as soon as the B becomes active, automatically B came to the life, the network is up again.
the election will happen again, and because C had stepped down as soon as the B was unavailable. Okay, so the election will happen again. That's correct, Kalyan. So Ananda, is there a doubt? So your question was why it is not working in less than 50%. All right. So Anand, could you repeat the question? Yes, Kalyan, go ahead with your question. I'll wait. So Kalyan's question is, in this example, we have three nodes where these data where this data is maintained to know whether it's 50 less than 50%. So all the nodes, when we are starting up the cluster, all the nodes know about all other nodes, and all the nodes know how many total nodes are there. Okay, so this data is maintained in the config when we are starting up our cluster. Okay, and when they try to, because continuously the whole system keeps on pinging each other, and the moment they realize that in the cluster there are total number of less than or equal to 50% node, if there is a leader, the leader itself steps down. Okay, good, good. So that's the question I'm coming to, Anand. So now Anand's question is that what is so big deal? Now we have these six machines, okay? We have six machines. In case three shut down, we still have three machines. We should continue our operation. Why are we harming the availability because of, even though we are saying we are not available, even though we all have three machines working, correct? Is that what your point is, Anand? So basically, you have still three machines available, and think about the situation when you have 100 servers. 50 servers are still available, and system says I am not available. Why is it so? Why is it such stupid decision? Okay, why is such inefficiency? So the idea is, imagine there are two data centers, data center 1 and data center 2. And in this one, let's say, as long as even one machine is up, there is an election of leader, and whosoever is the current leader takes the charge, becomes the writer. Now what will happen in this scenario? Imagine these two data centers, the cord between the network 1 and network 2 went down. Okay, now in this network there is ABC and another network DEF. All are pinging, and D is saying I have two available, and in this network, imagine that both of them elected a leader. In this network on the data center 1, A became the leader. On the data center 2, D became the leader. And both started accepting the write request from all the users, and effectively you have two inconsistent data sets continuously working. Okay, so you can see that if you have two leaders, multiple leaders, it's a very dangerous thing, and it's impossible. The whole data is inconsistent. You wrote one row in one database, you wrote another row in another database, and after that, after that, you try to retrieve from the first one, it says that the data is not available. And the client will, I mean, this whole purpose of having a database is defeated. Okay? Alright? So does it make sense to you? Now you can think about now you can think about that there can be only one piece of a cake which is bigger than 50%, right? There could be only one piece of a cake which can be bigger than 50%. If you have to cut the cake such way that there has to be only one biggest piece, then the only way to cut it is cut little more than 50%, and that one will be the biggest cake. Correct? And the same way manner, if we have more than 50% node in a network, that means that is the only network which we have, the biggest network we have. Okay? Therefore, there can be only one majority in the system, and therefore, because of the majority, if we are selecting a leader, then there will be only one leader at a time. And that is the reason why majority is required in case of this. Now we have an interesting question from Kalyan, and his question is, suppose we are removing one node from the cluster, that time will it be treated like as down? Okay, let me rephrase the question in order to suit one more thing which would be going in your mind. Imagine that we have realized that data center 2 is down anyway. Okay, and it's a real scenario that our three machines are down, but we want to carry on. In those cases, what you have to do is you have to shut down all three nodes and change the list, remove these nodes from the list, D, E, and F from the list completely, and then start again. So now our cluster is clear. Our cluster says that there are only three nodes. There are no D, E, F, only A, B, C we are keeping right now, and we are booting them. Okay, this way you have acknowledged that the new frame of the structure is this, and hence all the clients will be informed that this is the only system which we are running. We don't have six nodes, we have three nodes, and therefore the election or the thing with other node will not impact us. Okay, so once you acknowledge, once there is a human intervention required, that we acknowledge that okay, we have got three nodes down, let's just take them off the networks, change and restart our cluster by informing all the nodes that it's okay to have only three nodes. All right, does that answer your question, Kalyan? All right, an ensemble of 10 nodes can tolerate a shutdown of how many nodes? Anybody? An ensemble of 10 nodes can shut down of only 4 nodes, Lakshmikant, because as I told you that we require majority for the nodes to keep running. Okay? The moment the moment more than 4 nodes shut down, meaning 5 nodes shut down, the system becomes read only. Okay? The system becomes read only immediately. Okay? And therefore, so if 5 nodes shut down, then what will happen is it will realize that there is no majority, and whosoever is the leader will step down and the system becomes read only, and the reasoning is here. Okay? If if we are accepting less than majority in case of leader election, what will happen is there will be multiple leaders in the network. Okay. All right. These are the guarantees. Okay. Now, so this is another use case we have already demonstrated to you, that there are, on one hand, there are multitude of servers. Say for example we have 10 15 reason servers, uh, and there are many clients. Now the clients are asking which reason servers are up, which servers are up, which are down. In those cases, zookeeper comes very handy. Okay. Suppose out of 10 nodes, 6 are shut down and we restarted cluster, then it will have 4 nodes only. An election will happen. Yes, election will happen. While restarting, we'll also remove the dead machine from the list. Okay, so those are completely out of the out of the network. All right. So this is one use case when many servers